typically functions have more than one variable that they're depending on. And in this example, let's say we have a third variable, which is your dependent variable that depends on what x and y are. So let's suppose that this function is 2 to the power of x, that's exponential, plus 3xy. And if we want to find f of 0, -4, remember here the order is important. X is first, then y. So x equals 0, y equals -4. We're just going to take 0 and -4 and substitute them into this equation. So that means that f of 0, -4 is equal to 2 to the power of 0, because that's x, plus 3 times 0, and then times y, which is -4. 2 to the 0 is just 1. This, of course, is 0, and so we just get 1 as our output. If we evaluate it at the ordered pair -4, 3, so now x is -4, so this is going to be 2 to the -4 plus 3 times -4, and then y is 3, and I'm multiplying by y here, so I'm going to have this negative means I take the reciprocal of 2 to the 4th power, or the power of 4. So this is going to be 1 over 2 to the 4. And 3 times 3 is 9. So that is going to be equal to 2 to the 4 is 16. So 1/16 minus 36, which is -35 and 15/16. And if we want to find yet another, the function value at another point, we have f of 4, 3, let's say. This time for x is positive, so we're going to have 2 to the 4th plus 3 times 4 times 3. 2 to the 4 is 16. This is 36. And so that's going to be 52. So this is how you evaluate multivariate functions. Any questions on that? Okay. Let me do another example. You could have more than 2 independent variables. You could have 3, as in this next example. This time our function depends on x, y, and z. So z is an independent variable as well as x and y. And our function is given to us as 3x minus 6y squared plus 7z cubed minus 2. So this is a polynomial function in 3 variables. And we want to find f of 4, -5, 3. So we're just going to take 4 for x, y is -5, and z is 3. And so that's going to give me 3 times 4 minus 6 times -5 squared plus 7. Z is 3, so that's going to be 3 cubed minus 2. And evaluating that, I get 12. This is -5 squared, that's 25, times -6 is going to be -150. 3 cubed is 27 times 7 is going to be 189. And calculating that, 189 minus 150, 39 plus 12, that's 51 minus 2, 49. Okay? All right, so that's how you evaluate a multivariate function. Now, another question that you're going to be asked is, what is the domain, right? Whenever you have a function, that's a typical question, is what is the possible input for this function? And there may be restrictions depending on what your function is, so we want to investigate that. So let me look at some examples. So we're going to talk about finding the domain of multivariate functions. All right. The best thing is just to look at some examples. So we have a function in x and y, which is 3xe to the square root of 3 plus y. So we have a linear function in x, that's 3x, multiplied by an exponential function in y, e to the square root of 3 plus 1y. And the only situation here, normally any real number would work for x and any real number for y. So the way we would write that for the domain is we would write in set builder notation, because you can't do interval notation. Interval notation is only for single variables, because interval notation is for a line and you're in one dimension. So you have one variable x. Well, now that we have two variables, we have to use set builder notation. So we describe the set like this. We say all the ordered pairs x, y, such that, so basically all real numbers would work except what causes 3 plus y to be negative. We can't take the square root of a negative number. And so the requirement for this function is that 3 plus y must be greater than or equal to 0. And if you solve for y, you can subtract 3 from both sides of the inequality, and that gives you y is greater than or equal to negative 3. This is the requirement in order for a certain ordered pair to be an input for the function. So the way I write the possibilities, I have all ordered pairs such that y has to be greater than or equal to negative 3. And this perfectly describes the domain. And again, for multivariate functions, you're always going to be using this set builder notation. So let's suppose we have a function now, f(xy), which is the square root of y minus 9x. Again, we're going to use set builder notation to describe the domain, and we say all possible coordinates x, y, such that the requirement now, again, remember we cannot take the square root of a negative, so we're going to have the requirement that the radicand, which is what's underneath, y minus 9x, is got to be greater than or equal to 0. That's a requirement for a radical, or a square root in this case. And if I add 9x to both sides of my equation, I have that y is greater than or equal to 9x. Now, it would have been fine for me just to write this inequality here, but I'm doing it like this because this is how your textbook does it. So when you're doing your homework, you'll see they'll ask you, they'll want it in this form. So I'm just going to write it as this way. You're going to isolate the y. Okay. Any questions? Don't, feel free to unmute yourself or type in the chat box. Let me know what's going on in your thinking. This time now, our function is 5 over y plus 4x squared. And this time, the denominator is going to cause a problem if y plus 4x squared is 0. So we want the domain to be all coordinates x, y, such that this bottom is not equal to 0. So I'm going to write that over here. And if I isolate the y, I'm going to subtract 4x squared from both sides, and I get y is not equal to negative 4x squared. So I'm going to write that over here. So I think there are 3 problems very similar to this in your homework. And so now you know how to do them. I'd like to show you now an application of a multivariate function in the business world. I don't know much about business, so I don't really know what I'm talking about here, but maybe you do. Have you ever heard of what they call the price-earnings ratio? It has something to do with stocks. So a ratio is just a fraction, and we have 2 variables here. We have the price of a stock per share, per share it's got a certain price, and then you've got earnings from your stock. That's also per share. So you have a ratio, and we use R as the variable, and it depends on the price per share, and it also depends on the earnings per share. And you just take the price and divide by the earnings, and that's the price-earnings ratio. Okay, so for example, if P is $35.26, that's the price per share. And if your E, which is the earnings per share, is $2.18, then your ratio, price earnings ratio, is going to be the price, $35.26, divided by the earnings per share. And you get a number. It doesn't have any units. Ratios don't have units because typically you'll notice in this case the dollars cancel. So you just get a single value and this has some meaning. Like I said, I'm not a business person, so I don't really know the meaning of this other than it's just relating these 2 values together somehow. Okay. But I'm sure there's somebody out there where that means something to them, not to me. I just do the math. Okay. So that's an example of an application of this type of multivariable function thing. Any questions on that? This is another one that you'll find in your homework. And speaking of homework, why don't we just take a look at the homework for this section? Because there are a few other problems that I want to go over that are just looking at them, you may be confused about what they're asking. It's actually very simple, but I want to just walk you through it so you understand what's going on. So I'm going to share my screen. This is a typo. That is supposed to say homework section 6.2, but I will fix that, I suppose. Here's 6.1. And I want to take a look at, I think it's starting at problem 8. Let me see. Oh, that's the one I just did. Hold on. Let me make sure I'm sharing the right screen here. I'm not. There we go. That's better. Okay. And here we are. This is problem number 9 on your homework. So typically when we've graphed functions, we were just working with 2 variables, the dependent variable and the independent variable. So it was a single variable function. And we would graph on the horizontal axis the independent variable, and on the vertical axis, we would graph the dependent variable, y. Well, now we have 2 independent variables. So that kind of takes up the horizontal and vertical axis. And what do you do with the third, the dependent variable for a multivariate function? Well, here's our table. This is how it works. So here's one variable. That's the interest rate, and that's in a column, and then across in a row is the time in years. These numbers in the table are your third variable. So for example, here we have Kim is shopping for a car, she will finance $7,000 through a lender, and the table to the right shows the monthly payments per $1,000 borrowed at various interest rates and various lengths of time. So we're going to use this table to answer the questions. One lender offers Kim an APR of 6% for a 7-year term. What would be the amount of Kim's monthly payment? Now, first you have to know, what do these numbers mean? They mean this is the monthly payment for $1,000. See how it says right here? The table to the right shows the monthly payments per $1,000. Well, she's borrowing $7,000. So we are going to have to take these numbers and multiply by 7 to get the correct answer when we're finding the monthly payment. All right. So at 6% for 7 years in our table, here's 6% right here in the middle. This middle row represents 6%. And then we go to the column for 7 years right here, 14.61. Okay, 14.61 is the monthly payment per $1,000. She's borrowing 7, so we need to multiply that by 7. So I'm going to go over to my calculator real quick, and let's see here. I hope you can see my calculator. I mean, it doesn't matter because I'll go right back to the problem here in a minute, but okay, 14.61 times 7. So her monthly payment is 102.27. Okay, and I'm going to go back to my other screen here. And put in 102.27. Okay, so that's part A. The next part wants you to calculate what is her AP, or what is her monthly payment for 5.5% for 8 years. So here we have the 5.5%, that's the second row here. And then we go to the column where it says 8, that's 8 years. And $12.90 is her monthly payment for $1,000. And she's borrowing $7,000, so we multiply that 12.9 times 7. And I think I'm just going to do that by hand. That gives me 3, 14, that's 20. So her monthly payment is $90.30. Okay, now I'll let you do the rest, but what they're going to ask you to do now is to calculate her total payments from the start to the end of the loan. And over the first part A right here is over 7 years. So if you multiply by that 12, because you've got 12 months in a year, you're going to take this monthly payment, and she's making that payment for 84 months. So you're going to multiply that by 84 and you're going to get an answer. Then you're going to take this one. She's got 8-year term, so that's 96 months, and you're going to multiply 90.3 times 96, and then you're going to compare your answers, because it asks you which option costs Kim less overall, and so you're going to be comparing those two values. But I'll let you go ahead and do that. That shouldn't be too difficult. Let's look at the next two homework problems. And if there aren't any questions on this one, I'll go ahead and go to the next one. I just want to make sure I'm sharing the right screen. I am. And here we are. So again, we have a two-dimensional graph here, but we have 3 variables that we're looking at. So the horizontal axis is miles, and the vertical axis is days, and that's the input for your function. And then the third variable is represented by these contour lines. So the contour lines are constant values, where your function is constant at a certain value. So for the light blue line here, it's 77. For the green line, every point on this line for input will give you an output of 84. And the black line, it'll give you an output of 91. On the red line, it'll give you an output of 98. And finally, on the blue line, 105. So these values here along these contours are constant values, showing you the output. Now let me go back to my document, and I'm going to discuss for a minute contour lines. So contour lines, you may have experience with these from a topological map. And let's say you've got a hill, and you want to look at the elevation around that hill. And you've got on your map, you have an X and Y coordinate, if you will, that represents latitude and longitude. Well, the third variable that you're talking about is the elevation. And to show the elevation, you use a flat map, but you use contour lines. And on each contour line, so like at the top of the hill, there's going to be a certain elevation around the top of the hill. And then you've got another certain elevation below that, and another elevation below that. As you go down the hill, there's a new elevation. But along these lines on that map, so here, this point represents a latitude and a longitude on the map, and then the contour has a certain elevation, let's say 1,000 feet. I'm just making this up, I don't know. But so you've got 2 coordinates for latitude and longitude, and then you've got a third value, which is the elevation. And so contour lines enable you to take a 2-dimensional surface and represent a 3-dimensional situation. Okay, so that's enough about contour lines. Let's go back to the homework. And that's what we have here. We have these lines. These are contour lines. So we got to fill in this chart. And the situation that we have here is somebody's renting a truck. The cost to rent the truck is a function of the miles driven and the days rented. So the contour diagram of this function that we're talking about is right here. This is the contour diagram. We need to fill in the values that are represented by this diagram. So one thing you'll notice is, look along these diagonals here. Notice how it's 105, 105, 105 along this diagonal. Here, 98, 98, 98. So this is, you can see right now, that box is going to be a 98. Here we have 91, 91, 91, 84. So that's going to be 84. And what you'll notice is as you go from 77 to 84 to 91 to 98, you're adding a constant. 7 plus 7 is 84. 84 plus 7 is 91. 91 plus 7 gives me 98. 98 plus 7 gives me 105. So 105 plus 7, this box is going to be 112. And you know, because this sits on the diagonal, all of these boxes here are going to be 112. Now, how are these two tables related? Well, let's just pick a point here. For example, this point right here, it has miles are 28 and the number of days is 2. So from our chart, we have 2, 28, and you can see that that value in there is a 98. Well, look over here, 28 and 2, that coordinate sits right here on the red contour line. And look here, the red contour line has a constant value of 98. So that's where that 98 corresponds, this 98 and this 98 here. So you can see how that works going back and forth between the diagram and the table. Now, when you're starting just to pick up the truck, you've rented it for 0 days. You've rented it for 0, or you've driven it 0 miles. You've just gone into the shop. You've got the keys in your hand, but you had to pay something just for the use of the truck. It's a fixed cost. So that's your starting point of what you're paying out. And so just to get the keys, you haven't driven it yet. You haven't done anything yet. You just have the keys in your hand and you're walking out the door. You've got to pay something. Well, what is that initial value? That's what we need to figure out. And you'll notice that vertically here, everything is increased by 7. So going from this starting value, we add 7 to get 77. Well, that tells us that we're starting with 70. And I wouldn't be able to tell that from this chart because here at 0, 0, it doesn't give us a value. It doesn't show us a contour line there. So I wouldn't know that. All I can do is surmise that from the pattern that I'm seeing here, that to get the next value, you add 7 every time as you're going down the column. So that's how I know that that's a 70, okay? And finally, if you go from 70 to 84, you add 14, and from 84 to 98, you add 14. So going diagonally, and that's because you're going to add 7 to go down and then another 7 to go to the right. So you're going to add 7 twice. So going down this diagonal, you're adding 14. So 112 plus 14 is 126. And 126 plus 14 is 140. So now I've finished my chart. Once you fill in all those boxes, you can check your answer. Okay? And then they're going to ask you some questions. They want you to interpret the function evaluated at 0, 0, and I already discussed that. That's the fixed flat fee of $70 regardless of the miles or days that you used the truck. So that's the starting value, 70, and that's how you do that question. This one is similar, okay? The figure to the right shows the amount of an initial dose of 12 milligrams of drug in the bloodstream of a patient as a function of the drug's half-life, H, and the length of time since the initial dose. Okay, so the amount in the bloodstream depends not only on the half-life of the drug, but also on how long has it been in your body. And these are the contour lines that describe this situation for this function. These values here for the contour lines, 0.75, 1.5, 3, and 6, those are the output values. In other words, those are the amounts of drug in your system. And the x-axis is the time, is the horizontal axis is time, and the vertical axis is your half-life. T and H are both input values, and the contour values are your output values. So asking the question now, why do all the contours pass through the origin? There are a number of ways of interpreting that. Basically, the amount of, let's see, if the drug has no half-life, then it's not going to have to decay. It takes 0 minutes to decay. Obviously, option B is not the correct answer. The patient died on the operating table. No, that's not the right answer. The amount of drug has decayed completely at that point. I would just say D is the correct answer. Find the amount of the drug if T is 3 and H is 1. In other words, it's been in your bloodstream for 3 minutes and the half-life is 1 minute. What is the amount? Well, how do we calculate this? We go to our table here. Let me expand this. T is 3, so that's right here. Here's the t-axis, 1, 2, 3, and the h is 1. So if you go up to a height of 1, notice that our point lies on the pink or the fuchsia contour line. So the value for every point on the contour line, the amount is 1.5 milligrams. And the way we interpret this is an initial amount of 12 milligrams with a half-life of, it's given to us, the half-life is 1 minute, right? And the time is 3 minutes. And remember, on our contour line, it was 1.5 was our output for that. Okay, so that's how you do those problems with those contour lines. And